just like the quadratic formula, completing the square works for every quadratic equation that we need to solve. Okay? But sometimes completing the square, we get some fractions involved, so it becomes, there's some different cases that I want to make sure we bring up. Okay? So here's one of the cases, and this is the case where b is odd. So in this case, our b coefficient is -3. So that's, we got something to think about here. All right. So let's look at why this is an issue. So if we think about completing the square, right? If we think about the visual we used in the last video, we would have x squared. And in this case, I would have 3 of these x rectangles to try to distribute or put on each side. But I can't split them evenly. Like I could put 2 here and 1 there, but then that's not a square, right? So the visual kind of doesn't hold up for this, right? But the ideas from the visual are the same, right? So if we think about what we did is we have x squared, and then we take whatever our b term is, and we divide it by 2 to place those rectangles evenly on the sides. And then the number we need to complete the square is whatever this value is times itself, so b over 2 squared. Okay? So this is how we find the number to complete the square. So we're going to use that idea to help us in number 1 here. All right, so let's do our first things first. Let's minus 7 on both sides. So we get x squared minus 3x. I'm going to leave some space, equals -5. Okay. Now, if we're going to find what we need to complete the square, we're going to do b divided by 2 squared. So over on the left here, all right, I'll kind of do some side work here. We've got b, which is -3 divided by 2 squared. And we can, when we have a fraction squared, we can square the numerator and the denominator. So -3 squared is 9, divided by 4 will be what we need to add to both sides. So I'm going to say plus 9 over 4, and then we have to add 9 over 4 here as well. Now this left side looks complicated, right? But if we think about what our square would be, right, we would have x, right, minus, and then these sides would be b divided by 2. So in this case, that's 3 divided by 2 squared. Okay. And then equals, I want to write this as one number. So I have -5 plus 9 over 4. If I think about -5, that's the same thing as if I want a denominator of 4, we need -20 as our numerator. Okay. So we have -20 over 4 plus 9 over 4, and that's going to equal -11 over 4. And move this down a little bit here. Okay. So we have, oops, gotta keep it negative, -11 over 4 on the right side. Now, completing the square is the same to finish out. We're going to take the square root of both sides. Right. So on the left side, we just get x minus 3 over 2 equals, now square root of -11 over 4. We still need our plus or minus. And if I want to simplify this, right, we can take the square root of the top. The square root of the bottom is just square root of 4. We know square root of 4 is 2. Now square root -11, right, this is where our complex solutions come in. It's the same process. We just got to know, hey, if that's a -11 under there, we know we have an I out front, square root of +11, and that is how we simplify it. Okay. So if we go back to finish our problem, if we add 3 over 2 on both sides, our final answer would be x equals 3 over 2 plus or minus, and we can take our simplified radical, I squared 11 over 2. And that is our solution. All right, I will go through B as well. If you feel like, hey, Mr. Warners, I got this, you can go ahead and do B on your own and then go on to number 2. Okay? But let's look at B here. So, first things first, let's move the 18. So we get x squared plus 5x equals 14. Okay. Now, what we need to add, excuse me. right, is we need to take half of b and square it. So that's going to be 25 over 4. So we'll say plus 25 over 4 plus 25 over 4. So our left side becomes x plus 5 over 2 squared equals, now we're going to do that same fraction combining over here. So if I want 14 to have a denominator of 4, I need this number to be 56, because that's 4 times 14. All right, and 56 plus 25 would be 81 over 4. All right. Now this is going to work out real nicely. I take the square root of both sides. So we get x plus 5 over 2 equals plus or minus. Square root of 81 is a perfect square, that's 9. Square root of 4 is a perfect square, that's 2. So we get plus or minus 9 over 2. And then when we finish our problem, we get negative 5 over 2 plus or minus 9 over 2. And we're actually going to get whole number answers here for both of them, I believe. Negative 5 plus 9 over 2 would be x equals, that's 4 over 2 is 2. And then our other one would be x equals negative 5 minus 9 over 2. That's negative 14 divided by 2 would be negative 7. Okay. So that is another completing the square example when b is odd. Now, to be honest, I would, for b, right, that's actually one we could factor. So maybe completing the square isn't the best way to do it, but it works for all quadratics. Okay? So go ahead and try number 2. And there is one more case we need to look at after this. So after you finish number 2, head to the next